Hey guys, this is Science Day 8. This science lesson is also a mixture of different skills that we've learned so far and a little bit of reading into graphs and figures to answer questions. So we're going to be doing some analyzing. So number 13 says, use your knowledge of science to answer the question. Which statement best explains how the nose and the brain work together? So I want you to think about how the eyes and the brain work together, and it's going to help you think about how the nose and the brain can work together. So A, the nose sends oxygen to the brain. Okay? Yes, but that's not the best answer, and I'm going to show you why. The nose sends signals to the brain about scent information. Okay? So think about the eyes. Did the eyes send signals to the brain about what it could see? Yes. So here it's saying the nose sends signals to the brain about scent information. So that would be a good answer. C, the brain sends signals to the nose. Well, does the brain send signals to the nose, or does the nose send the signals to the brain? So C would not be the best answer choice. And then again, D, the brain sends signals to the nose about sense of an object. No. Just like the eyes send signals to the brain, and the brain develops those images and compares those images to memories for us. So same thing with smell. The nose is going to send signals to the brain. The brain's going to put that information together, and it's going to compare it to its memory to determine what the smell is. All right, so here we have two graphs that we're going to have to analyze. It says Simon learned that sleep can affect the heart. He found data on the effect that sleep has on heart rate. These data are shown in graph 1 and graph 2. So in graph 1, we have the bedtimes, Monday through Sunday, from 8:10 all the way to 8:55. In graph 2, it shows the heart rates, Monday through Sunday. It starts off with 59 beats per minute all the way to 60.8 beats per minute. The person in the study has a usual bedtime of 8:20 p.m. and wakes up at the same time every day. So we have to assume that this person wakes up, say, 9 o'clock a.m. every day. Which argument is best supported by the data in the graphs? A, getting more sleep causes a faster heart rate. So if you're going to bed earlier, would you say that you are getting more sleep? Yes. However, if you compare that to over here, is that giving you the fastest heart rate? No, it's not. So A would not be correct. B, getting less sleep causes a slower heart rate. So if you're going to bed at 8:55 now, instead of 8:20 or 8:10, would you say you're getting less sleep? Yes. Is it causing a slower heart rate? No. Okay, so that one's not correct. C, a person who stays up later than usual will have a faster heart rate. So here we can see that this person stayed up longer than what they usually do. And if we compare that with the heart rates over here, are they getting a faster heart rate whenever they stay up later? Yes. So this could be the correct answer. And then D, a person who stays up later than usual will have a slower heart rate. So again, we have our person that is staying up later than usual, but when we compare that to his heart rates, are they slower or are they faster? Well, they're faster. So this one would not be correct either. So again, you're using your sources, guys, and going through each answer choice to pick out which one is true based on evidence. All right, 37. I want you to think about erosion and that Japanese tree that we read about that put its roots into the rock. And what happened to the rock? It broke. So it says Joseph observed workers removing ivy from the brick wall of his school building. So we have the bricks covered with ivy. We have Joseph removing the ivy from the bricks, and then the bricks after the removal of the ivy. So you can see that the bricks were nice and intact, and now they look kind of jumbled up like they're loose. So, which question should most likely be investigated to discover why the bricks shown in the drawing changed? A, did the roots and leaves of the ivy dissolve the bricks? Well, we still have the same amount of bricks, so I wouldn't say that that's the question that we're trying to investigate. Did the ivy leaves grow behind the bricks and push them outward? Well, again, we still have the same amount of bricks, so none of them are missing. So I wouldn't say that they pushed them outward, so that probably wouldn't be the best question. C, were the bricks loosened because the roots of the ivy grew in the cracks? Well, we can see that the roots of the ivy are there and the bricks are loosened, so that could possibly be a good question to ask. And D, were the bricks weakened in the winter because they were covered with frozen ivy? Well, we don't have any evidence that says that he's removing them in the wintertime or that the ivy was frozen. So this would probably not be a good question either. All right, number 41. This one is all about the rock layers and a little bit about the earthquakes and volcanoes that we learned about recently. The figure shows several layers of rock and a line where there was movement in the layers. So we have layers T, E, and Q, and then we have this movement along line B. So we're going to use this to help us answer our last two questions. So part A says, which set of statements best explains the order of events that formed the rock layers? A, the layers formed in the order Q, E, T. So they're saying Q formed first, then E, then T. Well, if you remember, where is the oldest rock layer formed? It's formed at the bottom, and the oldest rock layer came first. Just like if you have an older sibling, they came first. So that would put layer T at the oldest and layer Q at the youngest. So did they form QET? No. So that automatically puts A as incorrect. B, the layers formed in the order TEQ. TEQ. Is that true? Yes. However, there's a next part that we have to read. Afterward, the layers moved along line B. So here's line B. Did those layers move along line B? Yes. So far, B has proven to be correct based on the evidence from the source. C, layers T and E formed. So T and E formed. Then the layers moved along line B. Okay, well, what about layer Q? It says last layer Q formed. Well, if T and E formed and then line B came, yes, these would be shifted, but would Q be shifted afterwards? No. So this one does not have evidence to support that answer choice. And D, layer Q formed. So layer Q formed. Did layer Q form first? No. So this one is automatically out because layer T would have had to form first. So D is not correct based on our source and evidence. Part B, Which evidence best supports the answer to part A? Select the two correct answers. A, layer Q is at the top, so this is the oldest layer of rock. Well, we already said that it's the what layer? The youngest layer. So A would not be correct. B, layers E and T are at the bottom. So these are the oldest layers of rock. So E and T, yes, they are at the bottom. So that could possibly be correct, that they are the oldest. C, line B cuts through layers E, Q, and T. So the layers moved after they were formed. So line B is cutting through layers E, Q, and T. And they moved along that line. So that could be correct. D, layer Q is thicker on one side, so it formed after the layers were moved. Well, no, just because this side looks thicker than this side doesn't mean that one side's older than the other. Because remember, it all deals with the layers from bottom to top, not side to side. So this one would be wrong. E, layers E and T are thicker on one side, so they formed after layer Q moved. Well, again, it doesn't matter if layers E and T are thicker on one side. That doesn't have anything to do with how old they are or when layer Q was moved. So E would be wrong as well.